Hello, welcome to lesson 4.2 and 4.8. In this lesson, we're going to look at how transformations create congruency with our rigid motions. So with translations, reflections, and rotations. It would be a good idea if you had a sheet of paper out, and if you even want to have a scissors to cut yourself out a triangle to kind of work through this activity and really see how your rigid motions are helping to develop our ideas of congruency in chapter 4. This is a good one to kind of work hands-on with me as we go through the lesson to make sure you're understanding how the different sides and angles correspond to each other. I'm going to go ahead and pull up the notes first so we can talk about a few things and some definitions before we get into the activity. All right, in this lesson, we're going to look at constructing congruent triangles using the idea of rigid motion and identifying corresponding parts, and then developing the idea of writing congruency statements. When we talk about a figure being congruent, again, our congruent symbol, that equal with the tilde over the top, means we're going to have the exact same shape and the exact same size. So when we think about that definition-wise, we think about one figure could lie directly over the other and everything aligns or corresponds, as we'll start to look at with our construction. And that means then that all the measurements have to be equal. So the degree measures of your angles have to equal the degree measures of the angles they correspond to, if you were to lie one over the other. Or the length of the side has to equal the length of the corresponding side. If we want our triangles to be the exact same shape and size, they do have to have 3 equal sets of sides and 3 equal sets of angles. These can be created by what we called rigid motion, in chapter 9. So if we had a rigid motion, we know the figure cannot change when it's being moved, and we use that little arrow, in chapter 9 to represent a transformation. So keep in mind the ones that were rigid were reflections, rotations, and translations. Or if we do 2 or more of these, like we did in compositions. Any type of combination of any of these rigid motions will always create congruent figures. So what we're going to do to kind of take a look at this, is we're going to start here with what we're going to develop as a reflection. So I drew triangle ABC here because I had cut one out just so that we could see right here. And I did this in color just to make it a little bit easier to see on the video. But if we're going to perform a reflection, we're either going to fold in a line of reflection to flip that over, or in this case, we're just going to take our sheet of paper here because we're not concerned where the line of reflection is. We're just going to flip this over, to create a second triangle here. Now I'm going to do my best to just kind of trace over this. So that we can see here that these two would be exactly the same. Now, I'm going to go ahead and label these vertices here as J, K, and L. And what I want you to do is I want you to think about these right now, as to which angles they correspond to. So we should notice here that angle A, if I reflect that over or flip this over, angle A is lining up with angle K. So we know that one could lie directly over the other. So we know those have to have the same measurement. They're going to be congruent. So we would say that angle A is going to be congruent with angle K. And when I take B and flip that over to this side, B is going to line up with angle J. And then C is going to line up with angle L. Okay, this is a congruency statement. We are showing what corresponding parts between these figures have to be congruent, because that's the way it was created. Okay, so then the side lengths should also match up. So then I should see that side AB will become side KJ. And side AC, okay, if we think about this one here, AC, this side is flipping to this side here, which was KL. And then side BC, okay, is going to flip to side JL. So these are considered to be, okay, those 3 sets of corresponding angles and 3 sets of corresponding sides. If all angle measurements and all side lengths are the same, the triangles are going to be congruent. Okay, so what we want to be able to do now is take this picture here, okay, that we just constructed, and write out a congruency statement. Let me go ahead and see if I can fit this all. Doesn't look like I can fit the whole thing on our page here. Okay, but if I was taking a look at this triangle ABC, this is the one I started with. We know that that has to be congruent, okay, to triangle, okay, KJL. But what you want to make sure of when you're writing this congruency statement is you want to make sure that the angles, okay, are written in the order in which they correspond to each other. So we should see that I started with angle A, okay, in this triangle. Well, A was congruent to K, so then K has to be my first letter over here. Okay, angle B corresponds with J, so if I wrote B second, J has to be second over here. Okay, and then angle C corresponds with angle L, so if C was my third letter, it has to be the third one here. Okay, the congruency statement, when you write out that the 2 triangles are congruent, okay, have to align those corresponding angles, okay, within that statement. Now, this is not the only way to state that the 2 triangles are congruent. I could have said that my first triangle was triangle C to B to A, right? I could have started here. I could have gone from C to B to A, okay, to create that triangle. Well, if I went C to B to A, then angle C aligns with L, so I have to start that one with L. Angle B starts with J, and angle A corresponds with K. Okay, those all line up with each other. Okay, so just kind of be careful with what corresponds when you set up your construction. Okay, and then the same thing would occur if we were going to complete a rotation this time. And this time I'm going to rotate or do my rotation about point E. I'm going to make E my center point of rotation. Okay, so here's my triangle so that we can see that. Okay, this is what I'm starting with. And again, I'm going to rotate on point E. So I'm going to leave E fixed, and I'm going to rotate this, okay, out. I'm going to cover up my statements a little bit here when I went to set it up. Okay, but then it could rotate to this position here. Okay, where one triangle, okay, could lie directly over the other. I could move that one and line it up right over that one. They line up perfectly. These would be congruent, or would be a rigid motion. Okay, I'd like you to label this as F and this as point G, okay, in your figure. Now, before I put the other set of the notes up here, just look at what corresponds with each other. Okay, C actually moved to which angle? Okay, you should go C, okay, would move to F. Okay, so angle C would have to be congruent with angle F. D, when it rotates, is going to rotate to G. So angle D has to be congruent with angle G because one would lie directly over the other. Okay, and then angle E here rotates, okay, to angle E. Okay, those are the ones that correspond with each other. Now we can do the same thing, okay, with these side lengths. Okay, and I've matched it up here so that we can see. So then side CE in my original figure is now going to become side FE on the second triangle. Side DE will have to be congruent to side GE, and side CD will have to be congruent to side FG. Okay, so then when I make my congruency statement about my triangles, then triangle CDE has to be congruent to triangle FGE. And again, the order that you write those letters in is important. So make sure that your congruent angles match up. So angle C was congruent to angle F. So I see those are both the first letters of my congruency statement. D with G, and I can see those are both the second. And then E with E. Okay, those are both the third letters in that statement. So this would be a correct way to write that triangle congruency statement. All right, one more time. Let's go ahead and take a look at this, okay, with our last type of rigid motion here. If we were to construct a translation. So again, I'm starting with my triangle here, and this time I'm going to label my triangle as triangle X, Y, Z. Now, all we're going to do is move this directly down, okay, and keep a vertex right at point Z. Okay, so then this will just kind of continue in here. If I were to trace over that. And then what I want to do is I want you to label this as point S and this one as point T on your figures. Okay, now just careful, okay, with how they match up. And sometimes it's easier to see it with the color. Angle X lines up or corresponds with angle S. Angle Y will correspond with angle Z on my second triangle. Okay, so we should see that this angle here moves to this angle here at Z. But you should recognize it's not the same angle as the original Z. The original angle at Z moves to angle T. And then if we look at our sides and how our sides are matching up, okay, we should be saying that side XY, okay, which is right here, corresponds with side SZ, okay, so those will be congruent to each other. YZ is congruent to ZT, and XZ is congruent to ST. So when I write my congruency statement here at the bottom, my original triangle was XYZ, okay, X to Y to Z. So then my second one has to go the same okay, direction around, so it'll go from triangle S to ZC. Now notice we have two angles at Z. These ones are not congruent to each other, and we can kind of tell that because they're in different locations, okay, in our congruency statement. Here Z was the third letter, here Z was the second, because it's representing two different angles, okay? In this case, angle Z on my original triangle is congruent to angle T, okay? In the second triangle, though, angle Z in the second one, okay, then corresponds with angle Y in your first, okay? And then hopefully you can kind of see that. But you do need to be very careful when you have shared vertices, because we're not describing these angles with three letters any longer. We're just using the vertex. So then sometimes if you have more than one angle at a vertex, they're actually different angles. So just kind of be careful there, okay, with your construction. All right. Now, just a couple more concepts that are going to come into play, okay, within this lesson that I want to mention that came up in your text. So first you have what's called the third angle theorem. Okay, your third angle theorem tells you if two angles of one triangle are congruent to two angles of another triangle, then the third angle must be congruent. Now, I want you to look at that by what's occurring with their measurements. Okay, we should know that there's 180 degrees, okay, in a triangle total. Okay, if I have a right angle marked, okay, that's going to subtract 90 degrees off. If I have a 30-degree angle marked, okay, that's going to subtract another 30, and then we'd be left with 60 degrees, okay, for angle B. Well, if we know we have congruent angles, okay, in the second triangle, two of them, okay, we still have a right angle in this one, so we have a right angle in this one. We have a 30-degree angle. Well, we know the entire triangle is 180. If we subtract the same two values, okay, then we have to get that same number or same measurement of 60 degrees. If you subtract the same values, you're going to get that same measurement. So that third angle must also be congruent. So in this picture, it tells us that angle B will have to be congruent with angle Y. Now, I just want to kind of take a look at this sheet here to give you an idea of what some of these columns are going to look like when you need to set up a corresponding part. Okay, so we want to kind of be able to determine that by what we are told. Okay, so for instance, in this section here, we are given the congruency statement. So we know the triangles are congruent. Triangle MKL is congruent to triangle JET. Okay, and then here's the two triangles here. So I could take triangle MKL and place it over the top of JET. Okay, if we were to do that, we should see then that angle L, if I were to just translate this over and lay it over the top, okay, would line up with angle T. So I would say that angle L has to be congruent with angle T if I knew the triangles were congruent to begin with. I can also just tell that by the congruency statement. L is the third letter of my congruency statement here with my triangles. So it's going to have to match up with the third angle over here, which is angle T. Okay, but I can also see that in the diagram itself. Same thing can occur, okay, with the side lengths. MK right here, we should see if we just translate this one over, should match up with JE. And we can take a look at the congruency statement and see that MK is the first two letters in the congruency statement, so they have to match up the first two here. So we'll match up with side JE. For some people, it's easy just to kind of pick it out from the congruency statement. some want to actually see that rigid motion, I would see this as a translation, and I can see which parts match up with each other. Now, keep in mind, we can write our triangle congruency statement in a different order. So here, triangle ETJ. So I could start from here, E to T to J. Well, I can make that congruent to, well, then I want to just move it over to its part. So then that should be triangle K, okay, to L to M. Okay, I'm going to go around the exact same way in my triangle. Okay, but you can also tell that the angles still correspond with each other. So E corresponds with K. Well, in the original, E corresponded with K. Okay, then T should match up with L. Well, T did match up with L. Okay, and then finally J with M. Well, J with N. Those were both the first letters there. So your corresponding angles still always need to align inside your triangle congruency statement. So here's a triangle congruency statement. Okay, so just kind of be careful in matching up those parts. Okay, one thing to kind of keep in mind as we kind of wrap this up is you want to make sure that when you look at a figure, you can see those rigid motions. Okay, because then if you visualize, yes, this one's a translation, and I can see that these angles match up with each other. Or I can see they flip this over. I can see this as a reflection. So this angle is going to flip over to here. It immediately allows you to kind of visualize where those corresponding parts are located and identify those accurately. This will help us greatly as we move through chapter 4, because as we move into proving that the triangles are congruent, we need to make sure we're always matching up where those corresponding parts are located. So look for the rigid motion. All right, good luck with your assignment.